hope that it's not as bad with the headset. So for this question, we're going to peel the layers off one at a time, right? In this case, starting with f double prime, you undo it by anti-differentiating it, and you're going to get 7x squared over 2 minus x plus c. And we want to evaluate, because we know f prime of -1 is 5, we're going to evaluate this at -1 and set the whole thing equal to 5, right? So we're going to plug in -1 everywhere we see an x and set the whole thing equal to 5. So -1 squared is 1. So you have 7 over 2 minus -1, or plus 1, plus c equals to 5. And subtract 1, subtract 7 over 2, that should give us our c value. Many of you, I think, said that you got that already. You got 1/2. And once you have it, rewrite your f prime function, right? Your f prime function with the correct plus c is going to be, so you just put the plus c, which is plus 1/2 at the end. Good, good, good. Some of you, I see you got the second constant also correctly as -19/6. Let's see how we get that. So we're going to integrate each term one at a time. So what is the antiderivative of 7 over 2x squared? Think of x squared, it has an antiderivative of x cubed over 3, and that 3 in the denominator will be multiplied with the 2 in the denominator, right? So it's going to be 7x to the third over 6, right? And then this one, it will be -x squared over 2. The last one, integral of our antiderivative of 1/2 is 1/2 x. So now add the last constant, say plus d. And what we do know is that from up here, when you plug in 1 for x, everything should be set equal to -2. So now I'm going to plug in a 1 everywhere I see an x and set the entire thing equal to -2. At this point, so it's going to be 7 over 6 minus 1 over 2 plus 1 over 2 plus d equals the right-hand side. And I noticed that -1/2, positive 1/2, they're canceling. I can subtract 7 over 6 from both sides to get d. So d is -2 minus 7 over 6. And if you get common denominators, you're going to get -19 over 6. Good. I'm always happy to hear from the chat, like you saw what you did wrong, because that's the whole point. So even if you may not have gotten it first time around, if you were able to fix it, hopefully you won't do that mistake again. Hopefully you'll do very well on the test. But let us not forget, how do we leave the final answer? Not just the equals, right? We should leave the final answer as a function. F, or f of x, equals the entire function we got, and don't forget to add the constant that we just got there as well. So f of x equals the right-hand side. Great. Okay, so ready for another problem? Any questions about this one? Because I gave you plenty of time earlier, I went through it relatively quickly. But if you have any questions, please do let me know. And if not, we're going to go do some area problems now. Okay, I didn't see any questions in the chat. Moving along. Sorry. Okay. F of x equals 2x to the third plus 4. We want to find the area of the region between this function over the given interval. And if it says area, if it just says an integrate this, you don't even have to look at the graph, right? If it says area, it's always a good idea to look at what the graph is going to look like. In this case, it's the cubic function moved 4 units up. So very roughly speaking, this function might be something like this. And from 0 to 2, so we're talking about a region that is entirely above the x-axis. So this is what I would consider to be one of the easier area questions, right? When it doesn't change from positive to negative or vice versa, it's more of a straight shot that we're just going to do it in one integral. It's going to be an easier question. So to do that, how will I set it up? Integral from where to where of what? So since we're integrating from 0 to 2, always limits come from the x-axis, right? Always the lower one, comma, the upper one from the x-axis, so 0 to 2. And the function we're going to be integrating is that whatever function is given to us, so 2x cubed plus 4. And we have learned that this method of integration is such a nice, simple way to find an area, because the other way we've done it only once, was set up summations, rectangles, let the rectangles increase in number. It was a mess, right? So this is the shortcut way that we've learned to find area under a curve. So I'm going to give you a little bit of time to go with that, but also I'm going to give you time also to work on this problem. So if you finish that one quickly, please also try this one. This is an upside down parabola, negative x squared plus 16. For this one, they want to know the area between f of x and the x-axis. Over the given interval from 0 to 5. And if you graph this, you're going to see that sometimes it's positive, sometimes it's negative. This region that they're asking us consists of two subregions, a positive and a negative. So we learned last class that to be able to do an area problem like this, you have to split it and do it in two integrals, right? You're going to integrate this from 0 to 4, and then you're going to integrate this from 4 to 5. So I'll give you a little bit of time on both of these questions. And by the way, how do I even know this is going to be the point 4? You should be able to determine that without even a graphing calculator. To find x-intercept, you set the whole function equal to 0, right? And you solve for x. So even though you're going to get plus or minus 4, we're on because the region is only a positive region, so we're only going to take the positive 4 for our purposes. So that's the intersection point right there. Okay, so a little bit of time for you to work on this, and then we're going to discuss your answers to both questions in just a little bit.
Could we use that one rule to just do from 0 to 5?
All right, that would give you the value of the integral from 0 to 5, but the value of the integral from 0 to 5 is not going to give you the area. If the problem says area, it's always going to be a little bit trickier, in the sense you have to split the regions, you have to do them separately because you need to add the absolute value of the two regions to each other. The other property we learned was the property of integrals. Like if all you want to know was what is the integral from 0 to 5, you could integrate that, but that is not going to give us the area. Okay, the integral from 0 to 5 is indeed integral from 0 to 4 plus integral from 4 to 5. But if this is a negative, let's say this area is negative 2, let's say this area is positive 5, okay? So 5 minus 2 is 3. This integral would give you an answer of 3. Okay, but if you truly want to find the sum of the two areas, you have to add the absolute values of the regions. So that's why if the question ever says area, red flag, like start circling the word area, underline it, tell yourself, okay, this is going to be a more challenging question than everything else. In the sense, I may need to split into two regions and I may need to add the absolute values of the regions. Because it says area and area can never be negative, we need to take the absolute values. Okay, so now I'm going to give you a little bit of time to work on it. All right, so what do we get for the first one? So that one we just integrated, right? We're just going to integrate 2x cubed plus 4 from 0 to 2. Anybody who got an answer for that one? Okay, I'm glad to see a few of you already got an answer. So let's go over it together. Good. Several of you got 16. So first we anti-differentiated. That region was a straightforward region in the sense we didn't have to split in any further, right? We just integrated 2x to the 4 over 4 plus 4x. The limits are from 0 to 2. Plug in the upper limit. 2 to the 4 will give you 16. 16 over 4 is 4. 4 times 2 is 8. And then plus 4 times 2, also 8, so the sum will be 16. Of course, we always plug in 0, but in this case, you subtract 0, so that doesn't change the answer. So upper limit minus lower limit, we're getting 16. Okay, so I hope everybody got that one because that was a relatively straightforward setup. Right? And if you didn't get it, I hope now you understand, the simple ones, you should not miss those questions. Everybody should be able to get 100% of the class should be able to get when the question is about area and there's only a positive region, okay? Now, for the ones with a negative region, or it dips plus and minus, sometimes it's positive, sometimes it's negative, then we split into two subregions, right? In this case, from 0 to 4 and then 4 to 5, and then we're going to add the absolute values. So there we're going to do it in two subregions. Go from 0 to 4, anti-differentiate the function, which is negative x to the 3 over 3 plus 16x. So again, I'm hoping that you had time to work on this question already. And so now we're checking your answers. So now you plug the upper limit in, minus you plug the lower limit in. Now, should it surprise us that we get a positive value for the first region? From 0 to 4, we're getting a positive answer there. Should it surprise us? It shouldn't, right? Because we can clearly see this region is above the x-axis, and we do expect to get area here, the integration here, to be positive. So we're going to use it just as it is. The second region, on the other hand, we expect to get a negative answer, right? And there we're going to take the absolute value. So I want you to remember something. If the question ever asks you, integrate this function, that's all they said. You don't have to look at a graph. You don't have to take absolute values. Just integrate it, plug the numbers in, you're done. Only if the question says find area, that's where we need to be a little bit more picky. We look at the region, making sure it's positive, if not, split it up and so forth. So now when we integrate from 4 to 5, we expect to get a negative answer. Did anybody get that part? Integral from 4 to 5. What did you get there? So same antiderivative, you plug the upper limit in, minus plug the lower limit in. When you plug the lower limit in, we already got that up there, right? 128 over 3. I'm just going to use that same value here when I subtract. Plug in the upper limit in for x, so 5 and 5 here. So we just simplify all of that. It shouldn't surprise us. We'll get a negative. Indeed, okay, some of you are working on it. A few of you got negative 13 over 3. Okay, I'm going to wait for a moment to make sure that you agree with negative 13 over 3. But remember now, this question did mention the word area. On the top there, they said they want to find the area of the region. So because it mentioned the word area, we're going to take absolute value of that subregion. So area of that particular region will be negative absolute value of this, which is positive 13 over 3. Great. One more person got the same answer. So now how do we finish the problem now? To find the total shaded region between the function and the x-axis, we must add the absolute values. So we're going to do that. We're going to add the absolute values. So this is 13 over 3. This is 128 over 3. And I believe there we're going to come to the same conclusion as Scott and Megan. So it's 141 over 3, which is 47. Wonderful. And I see Mary Jo got the same, and Adrian got the correct answer in the second part. So Adrian, all you have to do is now add these two answers. So you got the first region, you got the second region. Take absolute values, which we did, and add them up to get the very final answer right there. Okay, one more review question. This time, let's do a couple, at least one question on optimization, and maybe one where we're only going to set it up. Yes, area is always positive. So if the question in its wording uses the word area, you got to look at a graph, split into subregions, add the absolute values. If, on the other hand, a question just says, okay, what is the integral from negative 2 to 5 of, let's say, negative x cubed plus 17 or something like that, but nowhere in the problem it used the word area, we don't care if this function is positive or negative. This is just a practice question on integration. In that situation, all you do is take the entire derivative and plug in the limits, upper limit minus the lower limit. But if it says area, we have to be super, super careful. Okay, so you have seen a question like this before, but just to remind everybody about the process for optimization. So we have a box where the length plus girth has to be 180. it's a square base, so it's x by y. So we must adhere by this criteria that lengthless girth must be equal to 180. And at the same time, we're trying to create the largest possible box that will follow this constraint, the largest possible box. So when they say largest box, so look in the on the test for wording like largest, smallest, maximum, minimum. Then these are your optimization questions, right? For optimization questions, find out what do they want to maximize. In this case, largest box, they want to maximize the volume, right? Volume here is going to be x squared times y. And what is given? Length plus girth is equal to 180. So they give us length is y, girth is the sum of the cross section. So if you go around it, this way, this way, this way, this way, that's 4x. That must be equal to 180. And just a quick refresher, how do we solve optimization problems? Whatever it is you're trying to maximize or minimize, you want to get that in one variable only. So in this case, when I maximize the volume, I want this in one variable only, right? So I need to solve here for y. And then I'm going to substitute that to the function we're trying to maximize. Since we're trying to maximize volume, volume is x squared times y, and now we know y is 180 minus 4x. So we have our volume function. So remind me again, what do I do with this? If I want to find the maximum of the volume function, what should I be doing right now? First, I should be simplifying it, right? But what should I do after I simplify it? If I'm trying to find the maximums of this function. Remember, to find the maximums or minimums, we need to find where slope equals 0, right? Where the first derivative is equal to 0. So we cannot find x just yet. Exactly, Andy and Mary Jo. Let's first take the derivative and then we're going to find x, right? So let's do that. So let's take v prime. Sorry, that's x cubed over there. So x squared times 4x is 4x cubed, right? So we have 180 x squared minus 4x cubed. The derivative is 360x minus 12x squared, set equal to 0, and solve for x. Let's take out a 12x from both of them. So here we're going to have 30 minus x. So x equals 0 or 30, but 0 will give us no box at all. So let's go with the answer x equals 30. And if x is 30, what is y going to be? So go back to this equation, right? So 180 minus 4 times 30. So 180 minus 120 or 60. And when you give the dimensions, so please give all 3 dimensions. 3 dimensions are x by y, right? So it's 30 by, and here units are centimeters, by 30 centimeters by 60 centimeters. And they might also ask you, what is the largest volume that you can enclose given the constraint that length plus girth must be 180. In that case, you just plug everything back to the volume equation or multiply these dimensions, you'll have the largest possible box. So that's just a very quick review of optimization. We find out what is to be maximized or minimized. That's usually not equal to a number, right? It's just a function. But then they give you an equation like a quantity equals to a number. This is your constraint. Solve for one of the unknowns in there, get it in terms of the other, get your objective function, the one you're maximizing or minimizing in one variable. Don't forget, you're going to simplify it, take the derivative, and then set equal to 0. If I want to confirm that this is indeed a maximum, what would I have to show that this is indeed a maximum and not a minimum? I would have to take the second derivative, right, and show that the second derivative is negative at that x value, because that would mean it's concave down. That would mean that the point that we obtain indeed is a maximum. All right, this one we're only going to set up. Yes.
No, I asked you after class.
Okay. So let's try to see if we can set this one up. We have a box, a luggage in the form of a box. And the sum of length plus width plus height has to be 234 centimeters. But we have an additional requirement that the dimensions are W by 2W by. In other words, the length of the base is twice the width. So it's not a square shaped anymore. So if this is W, this is 2W. And the third side, let's say it's H. So the sum of all the three dimensions must be 234. The sum of length is length, width, and height. So W plus 2W plus H must be equal to 234. That's a given. And we're trying to create the largest possible box. We want to maximize the volume of the luggage, right? So we want to maximize. Okay, what is the volume of this luggage? Here you would multiply all the three dimensions with each other, right? W times 2W times H. So there you're going to get 2W squared times H. So if you simplify the first equation, you get this. From here, you need to solve for H. H equals 234 minus 3W. So you get H from here. And then substitute back in here to get your volume. Once you have volume in one variable, what are you going to do with that? Just like above, right? Simplify it, take the derivative, set equal to 0, but whatever it is you're trying to maximize or minimize, it has to be in one variable only. If I had more time, I was also going to do a couple more optimization questions, and these were the questions I was going to do. These are the ones where you minimize a quantity like a surface area or cost. I think you do the same way, right? You set up a function you're minimizing, take the derivative, set equal to 0. So these are two additional good questions. You're going to see problems like these in the review sheet that I gave you already in that chapter. So make sure that you do a variety of optimization questions as you're getting ready for that test. And don't forget, we didn't have a chance to review average value. So make sure you're familiar with that 1 over b minus a times integral of the function. And go over the lecture notes for the last section that we just covered today and last class. So, you know, do lots of practice, homework. You're going to do great on the test. Just keep practicing, okay? For that, last question, let me also leave you with an answer there. The answer there will be 52 by 104 by 78. 52 by 104 by 78. So that way you can finish this problem and check your work. Okay, so with that, let me pause the recording. All right, so I did not get a chance to complete this problem in class, plus a couple or several more review questions that I had identified I wanted to do in class today. So I'm going to add them as a bonus material at the end of this video. If you have time, you can watch it. As a matter of fact, what's best for you to do, I would say, is like when you see a question, first try to work it out yourself, pause the video, and then fast forward and then just look at the results, compare your answers. So you don't really have to watch this video as much as really do the problems and check your answers, okay? So for this one, we had already set it up together. 3W plus H equals 234. From there, we can solve for H and then substitute in here in the volume equation. So 2W squared times 234 minus 3W. So that's being substituted in for H will give us our volume equation. At this point, let's go ahead and distribute 2W squared. So we are going to have 464W squared minus 6W to the third. So go ahead and further differentiate this. So now that we've simplified it, differentiate this, bring the power 2 down, subtract 1 from the power, right? And same thing here, differentiate 6w cubed as 18w squared. At this point, this is a derivative. So we set the derivative equal to 0 and solve for w. So I can try to factor out 18w. I can try to see if that goes into 936 evenly, and it does. So take out 19w, you're going to be left with 52 from the first term and just a w from the second term. When you set each one separately equal to 0, you're going to get 0 and 52. And remember, the 3 dimensions have to be reported for this question. Don't just stop here, right? So if w is 52, then the other dimension will be 2 times w, or 104. And the other dimension, h, will be 234 minus 3 times w. So 234 minus 3 times 52, and that's 78. Everything should be in centimeters, so 52 by 104 by 78 centimeters. Those are the dimensions that will give you the largest possible box with the given requirements. Okay, so I have 2 more optimization questions for you. Again, my suggestion would be read them, stop the video, and then come back and check your results. So you don't have to come and watch the whole thing. Okay, this would be really the best way to practice towards a test. Try to do it on your own first. So we have a cylindrical container with a volume of 600 centimeter cube. We want to determine the dimensions R and H that will minimize the surface area. So we want to end up with least surface area, least amount of material to create this box pretty much. And the volume equation for a cylinder is this, area of base times height. The surface area, because it's a closed cylinder, is going to be 2 pi r squared. You have the top and the bottom, and the side panel, which is 2 pi rh. The surface area of a cylinder I would give to you, but you should know the volume, okay? Now we know volume is 600, so set that equal to 600. And from here you can solve for h, right? H equals 600 over pi r squared. Now the one that we're trying to maximize or minimize, in this case it is minimize the surface area. We want to use as little material as possible to create this box with this given volume. It has 2 variables, r and h. So once you get this information that h is equal to 600 over pi r squared, you need to go back and plug that in. This would be a really good time to pause the video, finish the question, and come back, check your results. Cancel the pi's, one of the r's cancel as well. 2 times 600 is 1200. So this part will be 1200 over r. The first part is exactly the same. Remember, this is surface area, but we want to differentiate it first and then set it equal to 0. And why are we differentiating it? Because to find maximums or minimums, we need to know where a given function has a slope of 0. That's where we're trying to find and locate the maximums and the minimums. So the derivative of this will be 4 pi r minus 1200 over r squared. If you have any trouble with that, write this as 1200 times r to the negative 1 first and then differentiate. Now to solve this, you would add 1200 over r squared to both sides, multiply both sides by r squared, and divide by 4 pi. Be careful as you enter that into the calculator, use parentheses for the denominator, and don't forget to take the cube root. R will turn out to be 4.57 centimeters, and H, you can go back to this equation to figure out your H, it'll be roughly 9.14 centimeters. And if they ever ask you what is the lowest surface area for this box, you will put R and H back into the original equation. If it ever says, okay, demonstrate that this is indeed a minimum, not a maximum, you would take the second derivative and show the second derivative is positive at this R value. Positive meaning it's concave up. That means at the point obtained, we have a minimum. All right, one more optimization question. So this time we have an open box with a square base. It's supposed to have 18 cubic feet of material, so the volume will be 18. We're further given that the cost of each side for the base, each side of the base, so the side panels is $3 per square foot, and the cost of the base is $4 per square foot. What are the dimensions for the box of the least cost? We want to minimize the cost function. So for this box, volume is x squared times y. Surface area, because it's open, you only have the bottom and the 4 sides, so x squared plus 4xy. And further, we know the volume is supposed to be equal to 18. So set that equal to 18. From there, you know you can get y in terms of x right away, right? So you'll be able to get y as, in terms of basically y equals 18 over x squared. Now, before we can finish the problem, surface area is not going to be enough here. We also need to know what cost is. Since the base costs $4 per unit area, so multiply the base by 4 to get the cost of the base, and multiply the side panels, the total side panel, by 3. So now you have the cost equation. So 4 times x squared plus 3 times 4xy. So that's the cost of producing this box. And don't forget that y is equal to 18 over x squared. So now we can use that information and substitute that in here for y. So y equals 18 over x squared. So put it in there. And at this point, we're going to need to simplify it. So multiply 12 times 18, and then also x over x squared will give you just an x in the denominator. So we're going to get 4x squared plus 216 divided by x for our cost function. And to find the minimum for which x with this cost function be a minimum, let's differentiate it and set it equal to 0. So 8x minus 216 over x squared equals 0. Again, you're going to add this to the other side, multiply by x squared, and divide by 8. So if you do all of that, 8x cubed equals 216, x cubed equals 216 over 8, and then x equals the cube root of that. So this turns out to be a nice and whole number. Don't expect that to be every time. It could be a messy decimal, no worries. So x is 3. From there you can come here and find y. So 18 over 3 squared, or 18 over 9, will give you 2. So don't forget to give all 3 dimensions, x by y. So it's going to be 3 feet by 3 feet by 2 feet. These are the dimensions that will satisfy the given criteria of having a volume of 18 cubic centimeters, while at the same time using the least amount of material to create the box. Okay, so a couple more questions for our review process. For example, integrating something like this, how would you go about doing it? You would need to divide x into both of them because there is no quotient rule of integration, right? You got to simplify it first and then integrate. What about something like this? Again, there is no product rule of integration. So you got to first simplify by distributing this and then integrate it term by term. So please pause the video, finish those, and then come back and check your final answers there. So simplified it first and then integrate it. Same thing here, simplified it first by distributing and then integrated term by term. So please check your answers, and then I'm going to do the last 2 problems, find the average value and the net change theorem. So we're given a function f of x equals this. We want to find the average value of that function over the interval 0 to 2. So again, this is a good point to take a moment to solve the problem on your own. And when you come back, the answer will be shown. Remember the average value formula. You integrate the function, but you must divide that integral by the length of the interval, b minus a. Here, b minus a is 2 minus 0, or 2. So you're going to do 1 over 2 times the integral of the given function over the given 2 numbers. So we're going to integrate it from 0 to 2. So let's integrate it. So keeping the 1/2 on the outside, x to the 4 over 4 gives you 1 over 8 up front. X to the 4 over 8 minus 3x cubed over 3 gives you minus x to the 3rd, minus 6x squared over 2 gives you minus 3x squared. Antiderivative of 1 is x, so there we have our antiderivative, and we're going to evaluate it from 0 to 2. You can keep this 1/2 on the outside of everything. Just plug in a 2 for every x, minus plug in a 0 for every x. So here we're going to have 2 to the 4, or 16 over 8, minus 2 to the 3rd, which is 8, minus 3 times 2 squared, which will be minus 12, and then plus 2. When you put a minus 0, you get a 0 back, so that won't bring anything new. And at this point, just simplify this quantity, and you will have the answer. So the answer is -8. So the average value of this function over the given interval is -8. And finally, here we have an equation that gives us the rate of change of of the flow of traffic in terms of how many cars per minute through an intersection. Our job is to determine by the end of 6 minutes how many cars would have gone through this intersection. So you know the rate of change, and you're supposed to find the total number, right? So that is the perfect application of the net change theorem. You integrate the rate of change, cars per minute, over the given interval from 0 to 6 minutes, and that will give you the total number of cars that have gone through that intersection over that time period. So important to read the question. Notice that there's a rate. They can use the word rate. They can give you like cars per minute or liters per minute, then you know they give you the rate of change. That's this kind of situation when you're going to integrate to find total change, total number of cars or liquid that accumulated in a container. So we integrate the function, and we're going to do that from 0 to 6. 25t minus t squared, 0 to 6, and that will give us the total number of cars that have passed through that intersection. And the answer is 114, and in this situation it will be cars, total number of cars. All right, so the last thing you need to do beyond going through problems of this kind is don't forget to do the review sheet for the test, but also remember I gave you one video to watch, which was 2.5b. There's going to be one question from that. It's a 20-minute video. It's a relatively easy section, so please make sure you watch that. And there are a couple examples about that in the review sheet for you to practice. Good luck on the test, everyone.